All right. Welcome, everybody. We're about to get started here. Got folks trickling in. It's 5:30 p.m. here on clearly the west coast of the US of A. We're at 30 people so far, trickled in the last 20 seconds. We're going to give it another minute or two for anybody who's still popping in. Usually people trickle in for a minute or two. Give it another minute here. My name's Dan. I'm one of the co-founders here at Outco. Again, coming to you from the West Coast, as you can see, from my amazing penthouse hillside view of this iconic bridge here that nobody's ever seen. Yeah, grateful to have you be joining us. And I'm gonna also, I think I'm gonna share my screen at this point. So just give me 1 second. And if you're here, would love to. You're here and paying attention. Would love to hear from you in the chat. Would love to hear where you're calling in from. Clearly, again, we're calling from. Normally, we'd be calling from our office in San Francisco, but given COVID, we're not really allowed to go into the building, and it's just discouraged anyway. So, would love to hear where everybody else is calling in from. We've got, let's see, Los Angeles. We've got Richie's in Oakland. I'm also in Oakland right now. Instead of SF, we've got Montreal. Hello from Canada. We've got New York City, San Jose, calling in from Irvine, California, St. John's, Canada. 2 Canadians in the house, at least. Santa Cruz, New York, Pleasanton, New York City as well. A couple New Yorkers in the house as well. Salt Lake City. Hi, Ron. We've got New York, Florida. Glad you can hear us. Vic, thank you. Hello from Chicago. Hello, Rachel. Keisha's in New York. Nigeria, Samuel. I think you just took the cake for the furthest attendee. Welcome from the U.S. to Africa. Glad to have you here. Evanuel, Maryland, Toronto, New York City, San Diego, India. Okay, I don't know off the top of my head. I think India might. I don't know. It's pretty close. I think you're pretty close to like as far as being far away from SF. India is right up there with Africa. You got Chicago, Seattle, Boston, Toronto, Anaheim, the Ducks. We've got New York, Danny from Atlanta, Huntington Beach for Sean, New York, Charlottesville, Virginia, Delaware, Houston, San Jose. Hello, Soma Shekhar. And we've got Dallas and Montreal. So we've got a number of international folks joining us here tonight, depending on where in the world you are, maybe this morning. I'm not really sure, but glad to have you here. We've got 64 folks here with us. The vast majority of you, I'm guessing, are engineers. So welcome, glad to have you here. And gonna get started here. So I'm gonna share my screen. And thank you again for sharing where you're at in the US in the chat. Really appreciate it. Again, I'm gonna pop my deal here into full screen mode so you can see it. So if I could just get a confirmation in the chat that everybody can see my screen, it should say the Google interview. So if you signed up for the Google interview, you are in the right place. If you didn't sign up for the Google interview, your class is down the hall. It's a great joke to make online. So let's see. Anything else? I don't think so. So I think we'll get started here. So again, my name's Dan, one of the co-founders here at Outco. Very much my honor to have you all joining us here today. Just getting the rest of my windows squared away. All right. So I'm joined here by Ron, who's going to be working with us during the second half of this session here. He'll be working through a technical walkthrough. It's going to be using it's a binary tree problem. So stick around for that data structure algorithm problem walkthrough real time. You'll be able to ask questions as he's working through it. He's been at Outco since the very beginning, which you'll see is a non-trivial amount of time. Co-founder here at Outco, Richie and Chad. Richie, it's actually, this is his event. He organizes this all here, and Chad's sort of the mastermind behind Outco's getting our name out there and helping raise the awareness of Outco. So grateful to be here with the whole team and with you. So let's get underway. In this session, what we'll be covering, what we're going to actually, little housekeeping, we're going to hold questions until the end. We're actually going to be using the Q&A. Some of you have already discovered it. We'll use the Q&A. That's the best way to get questions answered. They'll be answered typically asynchronously. Sometimes you might be able to, in fact, it looks like Richie's already answering them in real time, but for the most part, we might have to delay those until someone else becomes available, myself or Ron. If you pop them into the Q&A, they will get answered. And then we'll be using chat for interaction. So if we ask any real-time questions that aren't covered in like a poll or something, just use the chat. We'll be interacting there as we just did with where we're all at in the format. Again, it's going to be a step-by-step walk through the interview stages with me. So how the Google interview process works. It's sort of a higher level and tips and interactions that you'll experience going through the interview process and how to make it to the next stage, up your conversion process for or conversion rate for each part of the interview process. And then the second part, which most of you are probably most excited for, is the live walkthrough of a Google interview problem. So you'll definitely want to stay tuned for that. That'll be coming up for the second half, again, with Ron, co-founder here at Outco. And real quick about us, so you know where this info is coming from, why it's relevant to you, why you should maybe listen to us. Outco is a software engineer career accelerator. We've been around for over 5 years now, coming up on, I guess, a year and a quarter here. Pretty exciting. It's great to be here for this long. We work with folks on CS fundamentals, machine learning, basically really any type of background you have, any type of engineer you are. That machine learning is just kind of there to demonstrate that we work with really any type of software engineer, even if it's getting into more like machine learning, data science types of stuff. But anything from, if you're low-level engineer like doing embedded systems, all the way up to front-end website design or website building, anything in between, regardless of where you are in the stack, we work with engineers like you. And in fact, usually we're working with job-seeking software engineers, and it's kind of neat to see. I just launched a poll. How many of you are actively job-seeking? Be good to get a sense of the, I think, 80 or so people we have here, 75 folks we have here. Be interested to hear how many of you are actively job seeking right now. We've got 62% of you are saying, yes, I'm actively job seeking. Another about 20 of you are not yet or considering it. I should say 30% are not sure, and only 3% of you, only 2 people here are not going to be job seeking. So you can see, I'll share the results here with you. You can see vast majority of folks here, the 75 of you, all have, most of you have something in common with someone else. At the very least, you're a job-seeking person. And in this next poll, we'll find out if you are, how many years of experience you are. We work with engineers of all different levels, all different backgrounds. We've worked with over 2,000 software engineers to date. And so I'd love to hear what your background is, what your experience level is. We've got about 20% of you have over 8 years of experience. So good chunk of folks here, pretty experienced. Another, let's see, about 20% have 2 to 8 years of experience, and a pretty sizable chunk here are in the 0 to 1 years, about 50%. So that's unusually high. And my guess is that because of the emails that we've been getting, which is a lot of folks who are anticipating graduating coming up, I think there's probably a lot of folks here who are saying, I'm going to be a new grad coming up in December or January, and I don't have a job offer yet. I need some help? So I'm guessing that's what's skewing us towards that level right now, but maybe we'll find out as we're going along. So let's see, what else have we got? We've got 2,000 software engineers that we've worked with to date of all different backgrounds. Again, we've had people who work at these big companies and are looking to get out of them. Believe it or not, that's actually a thing. We worked with a fellow who was the lead engineer on this Siri team at Apple not long ago because he wanted to get sort of the maximum return on his next step, and Outco is a great way to do that. But not only that, I mean, we work with people of really, illustrious educational backgrounds, and people with, frankly, education backgrounds more like me. Went to a state school, went to a boot camp, or went to self-taught or whatever it is that you, community college, maybe you uploaded it from the Matrix, however you learned the skills you got we've worked with people like you. So regardless of where you are in the process or how you got to where you are in the process, worry not. We've worked with folks like you. And one last piece here kind of about us is our success is dependent upon your success. We structured our program right from the beginning 5 years ago such that, we really put our money where our mouth is. 2 out of our 3 payment options are deferred payment options, which means you don't pay until you get an offer that you want and accept and are happy with. So that's us really saying if we're not able to put a program together that helps you get a job that you want, we're going to go out of business. We're not externally funded or anything like that. So me and none of my co-founders and I are independently wealthy. So this is going purely off of the success of you all, if you all decided to join. And so all this information is coming from that place. It's coming from 5 years of experience where we are putting our money where our mouth is and saying, gosh, this information better work or else, we're not gonna be able to pay the rent. And out here it is expensive. Check out our Yelp reviews. We've got 95+% are 5 stars. You can check that out. And this information, again, the folks who've worked here or currently do work here, depending, engineers, recruiters, L&D managers from companies that all of you are familiar with, Facebook, Uber, Amazon, Apple, many others. And the information, as I've already said, is particularly relevant to software engineers who are actively job seeking or considering a job change in the future. Even if it's sometime in the next year, this information will still be helpful for you. So without further ado, let's dive into the Google interview process. The stages outlined at kind of a higher level. You apply. Everybody knows that you got to apply. Resume, nobody really focuses on this. We'll explain why you want to actually put some time into your resume. It's actually more important than you think it is, even for you experienced folks, maybe even especially for you experienced folks. Google coaching call, nobody really uses this. You probably don't even know what I'm talking about when I say that. There's a phone screen. Again, same thing with the resume. It's just kind of something that's an afterthought. Oh, I'm going to talk to this recruiter. It's actually part of the interview process. Just looked at an email 2 hours ago where somebody was saying, they keep getting to the phone screen and getting knocked out, and it's because they're not taking it seriously. Text screen, you can get 2 of these, but we'll do, again, this is going to be the walkthrough. It's actually not with our lead engineer tonight. It's actually co-founder Ron. So definitely stay tuned for that. Again, be step-by-step, real time. You can ask questions as he's working through the problem. So it's a really good learning opportunity. Don't want to miss it. Even if no matter where you are in your technical background. The Onsites, it's pretty similar to the tech screen, so that you're going to get a walkthrough there too. We'll do an overview. Then we'll talk about the committee review, something most people don't even know about. And from that point, you're probably getting an offer if you go past the committee review, and that would be the negotiation phase. That's its own completely separate beast that is beyond the scope of this discussion. We can talk about game theory. We can talk about a lot of different things. But that is, just wanted to point out, that is part of the process. So. All right, so getting into that first piece, applying to Google, right? Again, most people probably think, I don't need to hear about this. There is kind of a key here, though, that you're going to want to learn about. So stay tuned. And the first part is, are you qualified? It's kind of a feeling thing. I'd love to hear in the chat, how many of you think you're qualified to work at Google? Again, just something to give a quick answer to. Can be yes, no, can be maybe, later, not yet, whatever you're thinking, maybe, not yet. Yes from John. All right, there we got a yes. Evanuel's thinking maybe in a year for Ian. We've got a couple more yeses, a not yet, a maybe, a couple more maybes. Hell nah. Yes, probably yes. All right, so we've got varying degrees of confidence or certainty amongst folks. I'll finish the boot camp in March. So yeah, we've got some new grads. It sounds like Keisha's looking for an internship again. Sounds like there's a lot of new grads here, or expecting to be new grads coming up. So, but even for you all, the answer is probably, or at least it can be probably with a little bit of work. Projects, experience, passion, all these things can be things that help you be more qualified or make you feel more qualified to the people who are making the decision about whether to move you forward in the interview process. And one of the things that you all can do right now to help you get more qualified is right after this session's over. If you're not, especially if you're not actively employed right now, or even if you are actively employed but your current role doesn't involve much coding day to day, looking at you like managers, people, more senior folks who might be taking more of a managerial type of role, or who are at some big corporation where you're not actively plugging in as often as you might want to. I've known people who work at like Honeywell, and they're just not doing much per day. Some of them aren't anyway. So one of the best things you could do is open up a Git repo and start building something right after this this call is over. Start building a project. Ideally, it's not just like sort of a crud project, create, read, update, destroy, like something a little more with a little more complexity than that. And just map it out and start to build it, know which technologies you're going to implement, and start building it. Then when you get into an interview, you can talk about what you're doing rather than, other than, well, I'm looking for a job. Obviously, like, you want to stand out as a software engineer. You want to be someone who's passionate about building software, and somebody who's actively doing it, which implies that your skills are kind of sharp, right? You're kind of constantly sharpening the sword if you're actively building. So that's something I would recommend everybody here consider doing if you're not actively coding in your day-to-day. But these companies, they're always hiring, especially software engineers. So it doesn't matter what level you're at. The big companies are hiring at all times, even in the depths of the pandemic in March, April, May. We saw them hiring engineers, and they're hiring again at all levels, whether you're junior, senior, anywhere in between. Google, these types of companies have a place for you. Of course, what it's really about is getting your foot in the door. Everybody knows about the standard application process, jobs.google.com. You submit your resume via this public job board. More than 60% of resumes are received this way at these big companies. This comes from this data comes from a company called Lever. It's a well-known data. Oh, it's actually not a data company, but they publish data in this space. But there's a second way in, that's the referral application process. Most of you are at least probably subconsciously aware that this is a process, but you may not have thought of it as being an actual formal process within the hiring departments of these companies. And it actually is a formalized process. And it's not about sort of putting the reality to, it's not what you know, it's who you know. And there's advantages to this. So, you submit your resume via Google employee, a referral to get you in the door. The conversion rate is 3 times higher. You're 3 times more likely to get an interview by getting a referral in at Google. And actually, I realized just before I got started, I meant to fix this, but it's actually, I believe, if I'm remembering correctly, it's over 60% of hires are made through referrals, not 50%. So you can see this disparity of, the majority of resumes are received, or applications are received, through their standard application portal, but more than half of the hires are made through the referral process. So this disparity alone, this one piece alone, can help you get your foot in the door, or in a way that's more likely to help you convert to being on that hire, which is probably why you're here. You're looking to get hired at Google, right? So definitely something that we teach here at Outco. We teach what's called a reverse recruiting. It's something that was put together by actually a former Google employee. And basically what we do is teach you how to talk to or reach out to recruiters, software engineers, hiring managers, these types of folks, in order to help you get plugged in to that referral network, and basically you develop a relationship with somebody at Google, and they end up referring you in, and they get a little bonus if they do refer somebody in. Usually they get anywhere from a couple thousand. Some companies it's up to $10,000 per hire. So definitely an incentive for them. And obviously an incentive for you as well. So that's the application. Next up, resume. Obviously, it's a key component of applying. For you, it applies, or why it matters for them, rather. It's time. Basically, they're trying to cut down the amount of time they invest in any given decision, right? The faster they can make a decision, the less expensive it is in terms of human resources. If they're having to put engineering time on making a decision whether or not to hire you, it's a much more expensive decision. So just looking at a resume and saying, is this person potentially a fit? Yes, no. very, very cheap. Sometimes even software can do it. So for you, however, it matters because this stage, or this your resume actually matters at every single stage of the interview process. Remember, every single stage that you go through, you know, the application, the phone screen, the technical screen, the on-site, the committee review, every single stage that you're going through, the people making the decision whether or not to move you forward, they're looking at your performance at that given stage, and they're taking into account your performance at the previous stages, but they're doing that while looking at your resume. So you want to make sure you invest the time to make your resume stand out as much as you possibly can. If you make your resume, you know, 2, 3, 4 times better than it is right now, or even just, you know, 50% better than it is right now, that might be the difference that puts you over to the offer stage. If you and, you know, everybody else you're competing against, there's probably going to be a couple, if not a couple dozen, maybe even more, who get those problems, the technical problems, correct, who solve them the same way that hopefully you do. And the thing that might push you over the edge is they're looking at your resumes and they say, this person who went to that Google interview prep class is the person that stands out. Holy crap, let's, you know, make them an offer. Or it might be the difference that tips you into, you know, you being able to negotiate for like a $10,000 signing bonus, $20,000, $50,000, whatever it is signing bonus you want, or, you know, offer you some leverage to make them just want to hire you that much more. So the resume, again, matters for every single stage. It's what you want it to be: one page, easily scannable, keyword search for, you know, technical, the technologies that they're looking for a given role, projects, numbers, these types of things. We'll get into a little more detail about that, but the key here is having those keywords that in the job description that you're applying for. Make sure there are at least as many as they can be truthfully reflected in your resume. ARM, this is actually an acronym that comes from within Google. It stands for Action, Results, and Metrics. And it's basically a way to break down your accomplishments, your bullet points that you're using to describe your accomplishments in your resume. So we'll talk about that here with an example. This is a real resume of someone who went through our program. This was their resume when they came in, and here's what we immediately recognize. They got their education right up at the top, and they've got their skills way down at the bottom. Anybody who's looking at your resume, the first thing that they're going to the reason that they're looking at your resume is to figure out, is this person qualified to work here? Could they work at Google? So the way they're going to be doing that is saying, do you have the skills to work here? So before we completely overhauled their resume, they had their education up top and their skills down at the bottom. And then after we worked through their resume, they've got their technical skills loaded at the top. This is our format, the way we help every person who goes through our program overhaul their resume. And you can see there's a little trick here. You got proficient and exposure as your skill set. So you can mention a lot more technologies that way and not feel like you're being misleading. Like, oh, look, I'm listing, you know, this person listed Ruby on Rails, and I don't even know what I'm doing with Ruby on Rails. It's been 10 years since I used it. Well, that's okay, because, you know, you're just saying you have exposure to it. You're not saying you're an expert or anything like that. So it can be a good way of getting you extra skills in there, backed up by then immediately after that with experience. Then you have your education following thereafter, and then backed up by project work. And again, ideally, you can see this person had a project that they've been doing. I'm not sure if this was independent or if this was with their work, but I'm guessing it was independent. But you want to ideally have projects that you're using to back up your, if you don't have a nice library of experiences that you can reference from your workplace. To get a little more specific in terms of the bullet points, and again, using that ARM acronym that comes from Google. This is a Google acronym. Look at the first bullet point in the before section. You can see developed and deployed automation software for configuration testing of nationwide station racks, improving technician productivity by approximately 20%. And then I don't think the bullets match here, unfortunately, but in the after, you can see optimized manual config searches by web scraping configuration pages using Ruby on Rails, and Nokogiri, removing need for 800 plus hours of manual configuration searches. So ignoring the typos of when I frantically typed that in there, that's not the way it looks in the resume, but you can see the point here is like saved 800, removed the need for 800 hours of manual configurations of engineering time. So here's what's happening on the back end in Google. Engineering managers reviewing this resume when they're deciding to move you forward, deciding how much to offer you, and they're going to see 800 hours and say, whoa, if I could contribute to my team needing 800 fewer hours of engineering time on our project, that's going to really make me look good. That's going to make my team look more efficient. Or if you added to the bottom line, oh wow, this person added $1 million in revenue, or whatever it is. You want to make it as sort of concrete as possible, and that's what ARM does. The action that you took, the result, which was removing the need for 800 hours of manual configuration searches, and the M is the metric, again, the metric being 800 hours. So that first bullet point, you can see improving technician productivity by 20%. That's kind of vague. It doesn't really mean anything. You want to get as specific as you can with these metrics in terms of what the impact was, ideally financially, to the company. So you can see the before and after, the before on the left, after on the right. The after, again, much more organized, much cleaner, much more easy to scan and find the parts you're looking for, and more of a standardized fashion. So Google coaching call. This is something, again, most people don't know about, and this is definitely something you should take advantage of. It's obviously it's optional, but you might be wondering, like, why would Google offer something like that? That doesn't make sense. Well, let's talk about what the mindset of a recruiter. And I'd love to hear in the chat, what do you think the purpose of a recruiter is? What is the reason that a recruiter is like, what is a recruiter's job? What do you think their purpose is with regard, especially to you as you're job seeking? Again, just in the chat, would love to hear what does the recruiter want to do as they're talking to you. It doesn't have to be anything too intense, doesn't have to be multiple sentences, just a couple words. Would love to hear. So find the best fitting candidate, help us get the job from Koi, find the best fit, keep you interested in Google. All right, so we've got some, actually, these are kind of optimistic responses. We get a lot of folks who wants to know if you're competent, right? Get to know the candidate more. So, right, so typically what we'll often see in these responses is, screen out the bad candidates, or try to figure out what's wrong with me, or something like that. So what are recruiters really doing, especially if they're talking to you? They've already looked at your resume and decided that this person theoretically can work here. On paper, they have what it needs to work here. So if you get past the resume stage, they've already made the decision that you can work here. So they want to get you hired. They have metrics that they have to hit every month. That's what their job is. They want to set you up for success, be it resources, be it planning for your future, insight on past job search, successes or failures, feedback on, maybe you've had a recent interaction with a recruiter, with a company, maybe it's not even Google, and they can offer you some insight and some feedback on why that experience went the way it did. So with the Google coaching call, the secret to getting one, it's pretty straightforward. You just ask for it. You ask for, ask them for, resources. Again, these pieces here: planning, insight, feedback. You can do it with the recruiter, or you can also ask them to schedule a call with an engineer. That's right. You could get a call with a Google engineer, someone who works at Google, and get feedback on where you're at technically, what you can do to prepare, the types of problems that they're going to be asking, what they're going to be looking for. So you can get the most up-to-date, and frankly, it can be a nice way to build rapport. You never know, they might be adding that into their report on the back end. Spoke with, engineer so-and-so, and they thought they sounded nice. Nevertheless, it gives you more data points for moving forward. Would definitely encourage you to take advantage of this. Most people don't know about it. Can set you up nicely. That can come before or after. Typically, it'd be after the Google phone screen, which is your discussion with a recruiter. Again, a lot of people don't even know this is part of the process, but it's another opportunity for them to say, okay, this person has a terrible attitude, or this person isn't even a software engineer, or this person has no idea what they're talking about, or this person just, for whatever, isn't a good culture fit, whatever it might be. So you want to take this part seriously. Any given stage from here forward, what they're looking at when they're talking to you, they're looking at two factors. And you can really boil any interview down to one of or both of these two factors. Can you do the job, and do they want to work with you? So can you do the job? In short, it's competence. And would I want to work with you? In short, that's your interpersonal skill set. So if you're someone who doesn't like people or doesn't like to talk to people, that would I want to work with you might not showcase well for you, and might actually be the thing that keeps you from getting a job. There's other factors that go into it as well that we'll be talking about, but at a high level, that's what they're looking for. So the phone screen, this is actually, again, from a Google recruiter. They look at coding and analytical skills, 25%. General cognitive ability, GCA, as they call it. That's their, again, another real internal Google acronym. 25% of how you do on this, whether or not you move forward. I don't know why my slide froze there. Leadership potential, 25%. So do you have a desire for future impact, potential return on investment? Something that a lot of people take for granted here is that you're supposed to be adding value to Google, right? They're not there to add value to you. So a lot of people will get a question like, why do you want to work here? And they'll say, well, I'd get exposed to the greatest technologies, and I'd get to work with the best people, and blah, 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 blah. Well, that's what you're getting out of it. What they want to hear is what you're going to bring to Google, what you're going to bring to that team that they're hiring you for. So you want to have answers like that ready to go, ready to how you're going to contribute to Google. And again, a lot of that's confidence. So that's something we really focus on here at Outco is helping folks build up their confidence. And there's other term, Googliness, as they like to refer to it in-house there. Culture fit, really what they're talking about is bias. Again, do we want to work with you? They'll couch it as values. Do you have values that align with our values? What it really comes down to is your ability to communicate who you are, what you want, and make yourself seem like someone who would fit in at Google. What humans want is to be around other people that they think are similar to them. This is where all of our biases at the end of the day come from. We feel in danger if we're around people that don't make sense to us. So it's your ability to convey yourself as someone who belongs at Google. Unfortunately, there are a lot of other biases that we just don't have any control of, that can be anything from ageism, sexism, racism. There's all these biases that creep in, be they hopefully not cognitive at the worst, but all of us are subject to them subconsciously. So again, another piece that we help folks work through here at Outco. Again, all these isms are things that are real and that people have to work through. So that's, again, another part of the analysis formula, both formal and informal, as it were. The phone screen, 15-30-minute phone call. It's going to be non-technical in nature. Maybe you'll get a little trivia type of question of I don't know, some trivia question about some language, but generally speaking, it's going to be pretty. Maybe it's some SQL question, whatever it might be. But they're going to be looking at a piece of paper that tells them what the answer is, and that's going to be the end of it. But generally speaking, it's going to be focused on this GCA, the general cognitive abilities, like what percentage of your job now involves coding. Tell me about your most recent project. Why are you the right person for the job? So the GCA is that last one. The first two, again, if you start a project right after, if you're not already working on a project, you get done with this Google technical interview prep class with Outco here, fire open a new project, and you can say, well, I'm not actively employed right now, but I am working on this project that's really amazing that does this, this, and that, or it's going to do this, this, and that, and here's how I'm building it out. Immediately, much better narrative that you're going through there than going through the I'm looking for a job narrative. Same thing with the hardest problem you've ever solved. Same type of pieces. Again, the Googliness, would I want to work with you? Tell me about a time you had to deliver multiple deliverables. Tell me what you dislike about having a manager. That middle one there, by the way, what do you dislike about having a manager? You can get these kind of questions that you're like, I have to answer this negatively. Like they're asking, and like, what don't I like about having a manager? Or, tell me about a time I failed or something like that. The idea is you actually want to take that negative and spin it into a positive about yourself. So for instance, what do you dislike about having a manager? Well, uh, managers, when they're stressed, maybe they can get, a natural human reaction is to become like kind of a micromanager, because we want to have control over things that we feel are potentially endangering us. So what I try to do is to really empathize with my manager, understand where they're coming from, and just be as proactive as I can in helping my manager work through their hurdles. Boom, you just turned yourself into like the greatest employee ever, and they were asking you something about what you don't like. So no, there are lots of little tricks that we teach here at Outco that can help you stand out in that way. Those types of questions, it's really easy to fall on your face. Phone screen performance is what's going to be most important there. We actually have a GCA rubric, and I wish it's usually linked in here, but for some reason the link didn't carry through. But we actually have a rubric. It's a score on 1 to 4 that you're going to be getting on 1 to 4 points that the recruiter's actually going to be scoring you on as you're answering these questions. And again, those scores carry with you all the way to the end. So you might have gotten all the interview questions right. Your resume might look really good, but you didn't take these questions seriously because you're like, they're not technical in nature, whatever, I don't need them. And guess what? 3-4 other people got exactly the same scores as you all the way through, except on the phone screen they got 1 extra point. They're the one that got the offer, not you. So at every stage, we're trying to set up our outcoders to be set up for success so that they can really knock it out of the park at every single stage. So you have every factor going for you, including your resume. Then moving on to the technical screen. So this is probably, again, why most of you are here is for the technical screen. Again, it's usually 1, you can get 2, and we'll talk a little bit about that. Again, for them, they're just trying to screen people out that make as minimal investment in making the next stage of the decision as possible. And again, for you, this factors into the final decision, just like any other stage of this interview process. For Google, it's usually 45 minutes, or it's 45 minutes usually with a hard stop, and the code must compile. Google's kind of notorious for this, that if whatever you've written at the end of this session must compile. So definitely recommend that you get accustomed to that. There is one exception here with the asterisk, or it's not even an exception. It's just like kind of like an edge case that if you get just right on the edge, you can get a second one. It's pretty rare, but the ones we have seen happen were when the person was communicating, and actually, you know what, we'll get into this. I'll remind myself to talk about how you can potentially get that second one. So you'll get a brief introductory question. It's really important that you don't blow that introductory question off. It might be like, tell me about what you're working on right now. Tell me about the hardest technical problem you ever solved. One of those other things from the phone screen bank up above. You're going to get a question like that. Don't blow it off. Take it as seriously as you would at any other point. We've actually had someone not get an offer. It wasn't at Google, it was at Facebook, but they all do the same thing. All these big companies do more or less the same thing in their hiring processes. This person knocked it out of the park with all the technical interview questions with the phone screen, but they didn't take this one brief introductory question seriously, and they actually got the feedback. We were lucky enough for them to be able to get the feedback at the end, and it was the one question they just kind of gave like a soft little bunt to, and they didn't crack it, and it cost them an offer at Facebook. Luckily, they ended up at Microsoft, but nevertheless, the lesson here is make sure you take that brief introductory question seriously. Take every question you get seriously. Don't blow it off. Don't think, I got to get ready for this technical stuff. I gotta answer the question. Then it's followed by a live coding session. Again, we're going to be doing a real-time walkthrough here with my co-founder, Ron, so definitely stay tuned for that. It's going to be a data structure algorithm performance question, and you want to focus on performance, time and space complexity. Big O notation. You want to make sure you've got that stuff down, and every single line that you write, you're referencing, the performance impact that this line's going to make, the performance impact that the way this implementation is going to have. That's the thing that little asterisk right here is referencing. The candidates who were constantly bringing everything they did back to performance were the very few who got almost to a compilable code, didn't quite get it, and the interviewer said, it's really clear you knew what you were talking about. I think just a couple more minutes and you would have had the question. Let's do this again. I'm going to set you up with another call, another phone screen, technical screen, if you'd like it. So you want to make sure you're focusing on performance. It's going to be a Google Doc. It's pretty unusual that you're writing code in a Google Doc, at least I hope. So again, that one, just the environment change, you're out of your IDE alone can create a bunch of different psychological things. So you want to practice with a Google Doc. We're going to show you how to do that here in the walkthrough. Some really important keys here to setting yourself up for success while working in an environment such as a Google Doc. You'll get minimal hints. So what they're going to be looking for is just that you know your stuff, and they're not going to be offering you any advice or anything like that, especially no insight into necessarily what's going on. They might ask questions for you to reflect on, but for the most part, you're going to be getting pretty much no hints. So don't think your interviewer is treating you badly, or that you're getting treated in a particularly harsh way. Unfortunately, that's part of the some might call it hazing process, but it's also known as interviewing out here in the world. So the intro question again might be something like, "What are you working on right now? How much time? Tell me about your favorite coding language, the purpose or complexity of your most recent thing, the approach to solving a problem." I've gone enough into that. I'm just going to breeze through that quickly. The technical question might be something more like, given a list of integers, find the frequency of a target. So, the question interview style can vary widely based on the type of, or based on the engineer. You could get one type of question one time and a completely different type of question another time. Google gives quite a bit of leeway to their engineers to decide what the questions are. You will not be able to pseudocode, so there's no pseudocoding. They don't want to see it. They don't want it. But what you can do is diagram. And what we teach here and what you're going to get in the walkthrough coming up is what we've developed here called ASCII diagramming. So it's something that you can do while you're working through your on your keyboard here, working through your coding, your Word doc. So definitely stay tuned for that. Determine constraints and edge cases. So for instance, is the integer necessarily, or is the target in the list of integers? Might be like an opening question that you give to the interviewer. You want to define these edge cases so that you know the problem that you're actually trying to solve for as you work through it with the engineer. And again, your code must compile at the 45-minute mark. You won't be able to test it. You won't be able to see if it's actually compilable, but you need to be able to write it in a way that, syntax, the semantics, everything work out such that you can actually compile it. So again, focus on the performance, time and space complexity. Ideally, at every single line, you're referencing that. Start with the best solution that comes to mind. I know you just said focus on performance. That doesn't mean if you don't have an optimal solution, don't start. Even if you've got this nasty brute force solution, start with that and iterate towards the next best solution that comes to mind. And you want to ABC, always be communicating. Always be communicating. There's nothing worse than, especially if you're online with somebody like we are right now, and imagine I got a problem and I'm going like this, right? I'm typing away and all you're looking at is my forehead as I'm not saying anything, and you have no idea what I'm thinking, and they're just going to space out and start watching cat videos on YouTube. So make sure you're always communicating. You want to treat them as a partner even if they're not helping you. It's a better experience if nothing else, and they'll come out of it feeling better about it if you've involved them. Again, iterate towards the better solution based on better performance. And again, Google nests their problems. Most companies do. You'll start off with sort of like a starting problem, and they'll either add constraints or evolve the problem as you're working through it. And again, you want to get to the solution as fast as you can iteratively. So the decision about whether or not you move forward, pretty straightforward. Technical screen performance. Did your did your code compile? Was it optimized? Were you easy to communicate with? The phone screen performance, again, your score there is going to factor in to whether or not they move you forward. They're looking at your full package up to this point. Same thing with the resume. They're going to be referencing that as you move forward, which is why every single stage of this process, you really, really want to be standing out. So then the onsite, the big show, the thing that everybody's certainly gets most excited for. So data structures and algorithms going to be the first piece of it. You'll get 4 to 5 questions, 4 to 5, like I guess you could call them interviews. Each one will be 45 to 60 minutes in duration. You'll get a 1 hour break for lunch. Sometimes, or generally speaking, they'll do a system design question, and you might get a code review question depending on the day. We've been seeing more and more code review questions coming into Google's Onsites. It'll usually be either on a whiteboard or a Google Doc. Again, Google likes to use their own stuff, so they use Google Doc. Most companies do try to use their own proprietary thing whenever they can. And again, you can pseudocode at this stage, but just like the text screen, text screen you can't. Here they prefer that you don't. We would definitely recommend, again, using the ASCII diagramming. The parameters here for the data structures and algorithms part is generally pretty similar to the text screen. So I don't want to go too far into it because especially during COVID, it's pretty much the same. So not going to go too far into it, but I do want to talk about a little bit about system design, especially for those of you who are more senior here. I know half of you are more on the junior side, so this won't apply as much to you, but for the folks beyond, who are a little higher level experience than junior, the system design is where you get leveled. So you want to make sure you're ready for this, because this is sort of where you're going to get, you're going to determine how much value, if money is your primary motivator anyway, or just how challenging of a role. When I say challenging, just like how high you can get leveled up. So system design, you definitely want to pay attention here. You'll get questions akin to, like build a movie ticket processing system, a parking lot, these types of things. And again, if you're a new grad, they're probably not going to ask you this because they're not expecting you to have experience having worked with any sort of systems level types of engineering. You'll get one system design question. That's typically it, maybe like design YouTube's recommendation engine, something like that. And you want to bring up edge cases, concerns, and trade-offs with regard to the technologies that you're thinking about implementing the system, sort of just generally speaking. Most people just kind of dive in and look straight at, oh, I do this and then I do this and this will be, the most efficient thing. Well, what they really want to hear is that you understand the variety, the breadth of different options available to you that you could use for implementation, and that you're taking those various elements into consideration as you're building it out. Because at any given time, there's always a trade-off. You implement it one way, or you choose one technology, or whatever it is. You're not choosing any number of other potentially viable options. So they want to hear not that you can just string something together that works, but that you're actively effectively optimizing what you're doing for the specific task at hand. And again, a lot of that's going to come through sort of like the macro level performance. So common pitfalls, it'll often be like you'll provide something that's too simple, or say something that's a little too simple. I put a load balancer in front of these machines. Like, what does that mean? And like, what's the purpose of this? And how specifically would you implement it? The sort of thing that starts to go too far in the other direction is, whereas you're not providing enough detail. If you start finding yourself getting into like talking about how you'd specifically implement APIs, or especially if you're writing code, then you're getting too into the weeds. Again, this is a systems level engineering piece here, implementation that you're talking about. You don't want to get too deep into the details here. It's not the intent of the exercise. You do want to talk about, what you do want to focus on is like services, data stores, off-the-shelf components, like how you're going to implement these elements and tie them all together into a cohesive system that has the ultimate outcome that you're looking for. Thoughts about how to organize and store data. It's really easy to forget about how you're going to be organizing and storing the data as you're working through the system. And other things like security. Are you encrypting the data? In state or in transit, whatever it is, there's these pieces. you're going to want to focus on not just sort of how the system works, but also what's happening within to the data as you're transporting or processing the data through your system. And again, other pieces like how to handle spikes in traffic or outages, power outages, you know, what happens to the data in these scenarios. So you could almost think of them as like edge cases, like system design, edge cases. Other pieces you're going to want to touch on there. Something that we teach here is dividing your whiteboard. So you're doing what we call system diagramming. As you're diagramming out your system here, you want to divide your whiteboard into 2, 3, 4 boxes, depending on the problem or how many steps you think it would be helpful to sort of drill down into with the interviewer. But the idea is you start out really zoomed out in one box, you know, really, really high level. And then in the next box, you're zooming in and getting a little more detail on what's happening at each step, and zooming in on the next box, getting a little more detail. Again, not talking about, you know, too specific of implementations, especially if you're getting in again to sort of APIs, code especially, but you should be able to sort of zoom in, and you should get a feel. The idea here is you're also getting a feel from the interviewer as to how much detail they're looking for. So it's this interactive process as you're working through these problems with your interviewers. So that's the Google Onsite in a nutshell. Again, the decision to move forward, again, it's going to be your on-site performance, obviously your analytical skills, coding skills, communications experience, technical screen performance, phone screen performance, the resume, again, coming back here once more. And if you get rejected at this point, there's typically not going to be any feedback. The reason being because it's probably that you didn't write what they were looking for in terms of a solution to a problem or multiple problems. So it's not worth them risking giving you feedback and that being taken as some sort of bias and them getting sued when all you did was just demonstrate that you're not ready to work there anyway. But let's say you make it past that. You make it to the Google hiring committee. A lot of times you don't even know you're there. Your recruiter won't tell you, or they might say the decision's pending. Something like that means you're at the Google hiring committee, which can be, again, another kind of point of whether or not you make it through it. Sorry, that sneeze was building up for a while. Basically, the idea here to offer or to reject, you know, if you've made it to the hiring committee, you've demonstrated that you have the technical skill set needed to work well at Google. And they're going to be, again, looking at all these same things: the on-site performance and score, technical screen, phone screen, resume. Basically, what they're trying to do is deduce whether or not you would actually do well in not just can you do the job, but would you really add value to the team? Do you make sense? Are you like a good fit? And this is also where the internal referrals really come in. If a Googler referred you in, this is where that stamp of approval from somebody already within Google is going to factor in. They'll say, oh, look, they've already got somebody here in Google who thinks they would factor, or they would contribute here. So again, the referral process really does matter, from not only getting your foot in the door, but also that end stage, because Googlers' opinions do matter. They actually do trust their process. If you do not get an offer at this stage, you might actually get feedback, especially if you ask for it, and especially if your recruiter's more of a senior or someone who's been around for a while and know that they can give feedback at that stage. Because in theory, you can work there. It's just for whatever reason, maybe it's not even because they didn't think you were quote unquote good enough. Just for whatever reason, you know, either somebody else or a couple other people just happen to have a more relevant experience background. But what they might do is hook you up with a different team to interview for. They might have you come back in a relatively short period of time. You don't have this 6 or 12-month cool-off period. Whereas if you fail on on the technical piece, you get a much longer period before you can reapply. So this can be powerful to know whether or not you made it to the committee review for moving forward. So that's the interview process in a nutshell. Real quick, going through again, you're about to be getting a real live walkthrough here with Ron. So stick around. These all the process, all the stages of the interview process. And hopefully you have a little bit better idea of how to navigate those and move forward. So we're going to get started here with the second part. We're going to take a quick break right after I give you one last offer, or one more offer here. And actually it's going to be 2 offers here. So first of all, if you'd be interested at this point, we typically get people asking about Outco. Can I learn a little more about Outco? We'd like to offer you to sign up for a free info session if you'd like. Totally up to you. We have them on the poll. This will be you signing up for an info session. Again, it's totally free, just a half-hour walkthrough with us. So I just launched it in the poll there. Feel free to click the day that you'd be most interested in if you would be interested in learning more about Outco. The nice thing about learning more about Outco is we try to be adding value to you at every single stage, so that even if you, and just being super transparent here, it's good business for us, right? If you liked your experience here at Outco and you're like, I don't need Outco, and you go try to prep yourself and you end up getting a job somewhere, great. And then you hear a coworker, I hate it here, I want to get a job somewhere else, but I can't get interviews. Hey, do you hear about Outco? So it's in our, I'm just being super transparent, it's in our best interest for you to have a good experience, checking us out. So if you go to the info session, we're going to offer you to sign up for a free visitor class as well, which is where you actually sit in and sort of like what it looks like to be in one of our classes. And that can be really beneficial. You'll learn some more techniques there for problem solving. We'll be working through a dynamic programming problem that actually has also been asked at Google in the past. So a lot of reasons there. And then from there, if you join the visitor class, then we'd encourage you to apply to Outco. And again, just checking us out. There's no commitment at any point until you're actually signing an agreement with us. But from there, what you get is a hacker rank. And if you don't pass the hack rank to join our program, you get a one-on-one with one of our technical staff members. And so that we call that the fundamentals check. The fundamentals check can be a good sort of benchmark for whether or not where you're at technically. So if you don't pass our fundamentals check to get into our program, that could easily be an indicator. That we have people all the time. I got a Google interview in 3 weeks. I don't got time for Outco. Okay, great. Well, they apply, they take our fundamentals check, and they don't pass our fundamentals check. Guarantee you 3 weeks from then, they did not pass their Google interview. So this can be a good feedback mechanism. So even you can take the fundamentals check, even if you pass, we'll offer you to join our program, and you can just say, no, thank you. But at least at that point, you've got you've got as much value out of us as you can. You've got the feedback from us as where we think you are. If we think you're ready to join our program, at least you're at that baseline. And all it's doing is just making sure that we think we could add as much value to you as possible at every single stage of our program. We don't want people joining and then like, shoot, I don't remember how to traverse an array. And then we got to invest a lot more time with you. You've got to invest a lot more time in that. It's just not fun. So what we're trying to do is just make sure you're ready to go, that you can get as much value out of the program as possible. That's the intention behind that. So anyway, hope you sign up. We've got 19 people signed up for tomorrow's info session. We've got 10 for Wednesday and 14 for Monday. So I'm going to leave that open for a little bit longer in case anybody's looking to join in. Unfortunately, I can't relaunch it, which I didn't think this through. And I'm sorry, Richie, I know you got that other thing you want me to do, but I can't think of a way to do it. I want to keep this open for at least a couple more minutes. So if you stick around, we're going to offer you one other thing. We're actually launching a Slack channel, which is going to be a community for job-seeking software engineers. There's no money. There's no anything you can join. You'll be a beta. You'll be joining it in beta. You'll be one of the very first people. You'll actually be sort of like a founding member of the Outco community. So would definitely recommend sticking around. We'll be offering you to sign up for that, and a lot of good resources, a lot of good stuff there. So again, we'll just we'll keep this poll open, and we'll offer you to join that at the end here. So all right, so we'll take a 2-minute break here. I don't know if we have anything else, but we'll go through the walkthrough in about 2 minutes. So if you got to use the bathroom, now's the good time. Ron's going to be working really fast. You don't want to miss any of it. So stick around. We'll be coming back with more if you need some food or grab some water. I'm going to take a quick drink here myself. And I'll answer a couple questions here while we're waiting to get going here. So I've been able to get interviews with Apple, Facebook, Microsoft, and Amazon. I can't get a call back from Google. What am I doing wrong? Could be a number of different things. It depends. I'm not sure if you're getting interviews at those other FANG, are those all FANG? Those are all, or FAMANG companies. It depends. It's kind of hard to say, Reed, without knowing more about you. I don't know what roles you're applying for with Google. I don't know what your resume looks like. My guess, what I would recommend, the easiest thing I could recommend, almost regardless of your situation, is reach out to people at Google and try to get a referral. I'd be willing to bet if you're getting interviews at those other companies, you should be able to get an interview at Google. And if you got someone referring you in, that might be the thing that just helps you clear that friction. Just talking at sort of a high level, it's kind of hard to tell without diving in deeper with you. I could try to do that at the end if you want. Stick around. Is it relevant for EMs? Off the top of my head, I don't remember what EM stands for. Engineering manager. If it's engineering manager, yes, definitely. So if you're talking about is this, the Google walkthrough was definitely relevant for engineering managers. The Outco program is also relevant for engineering managers. In fact, use an example here, Amazon, we have a really high hit rate with Amazon, offer rate with Amazon. And by the way, that's another example of the importance of the referral process. We have people at companies, one example of one of our best tracked examples right now is Amazon. And we have, I think it's a 90% interview rate at Amazon through referrals, which is pretty much unheard of. So, the other thing about Amazon, they reached out to us about a year ago, asking us for a year and a half ago, asking us for a partnership with Amazon because we had such a high conversion rate with Amazon. The reason we think we have such a, well, not we think, we're pretty damn sure about this. If you don't know Amazon's interview process, they have a thing called leadership principles that they interview on. It's things most engineers don't know how to prepare for. It's something that there's not like hacker rank for engineering or for leadership principles. So our program helps candidates really stand out on that. And that's what engineering manager roles almost are always higher on. They want to see that you can be a leader. That's something that we can help you really stand out for here at Outco. So those are the couple of questions I'll have answered for now. We're going to get started here with Ron, however. So Ron, I hope you're there. Yes, he is.
I am here.
So thanks, everybody. I'll stick around until the end. I'll be back for Q&A. I'll answer any questions real time. But in the meantime, you're in amazing hands here with Ron, and I'll leave it to you, Ron.
Cool. All right. Hello, everybody. My name is Ron. I just saw from all of your locations earlier that I think I'm the only person here from Salt Lake City. I'm glad that none of you are here because right now it is 30 degrees Fahrenheit and frigid. Frigid, that's all I'll say. Wait, someone wrote in the chat? Maybe they are? Okay, well, let's go ahead and get started. The agenda for now is I'm going to be going through the Google technical screen, what you can expect along with the process to follow. And while we're going to be doing this, I'm going to be going through an actual question itself in a Google Doc, which is the environment that they use. So real quick, let me share my screen with you all. Okay. And second thing I'm going to do is I'm going to take this link. I'm going to share it with you all as viewers, just so that if you would like to get a copy of this later on, be able to refer back to it, you can look at it. So just tossing that link into there. Click on that link, open it for yourselves. Okay, we see the anonymous animals already showing up. Let's go ahead and get started. So here we've got a problem. And the prompt itself is convert binary tree to linked list. We're going to talk a bit more about what goes on into later parts of the problem here. But first, a couple of things you want to ensure that you already have set up is one thing I always do is choose a font where you have a fixed character width with also fixed kerning between the characters. So I always just choose Courier New. It's one I'm used to. And this makes it so that what you're typing in here is similar to what you work with when you're using an IDE like Atom, Sublime Text, VS Code, whatever it may be. Another thing I'll do is I'll also reduce the font size down to 8. And you see I've kind of reduced it down. I've zoomed in a little too. And this is so that ultimately when we start to write out our code later on, we have more space. We can fit more characters, more words on a single line without spilling over to the next line. All right, but let's dive right now into the problem itself. Step 1. understanding the problem. What you want to do at this point is, you go into the technical screen. It's an hour-long session. You might have, like, let's say, 45 minutes or so within there to actually solve a problem itself. And during that time, they might just give you a prompt, convert a binary tree to a linked list. They might also give you an input-output case, but in the event that they don't give you one, go ahead and just ask for it. You don't have to kind of try to experiment or come up with one of your own. Just ask for an example input-output case. But immediately after you get that, after you type it down, write it down, or let's say they copy and paste it in, you want to create one of your own. And the reason for this kind of goes with the mentality of fail fast, that when you're in the interview setting, fail fast. Don't end up, wasting 10 minutes solving the wrong question. By creating a second example case, you can verify right away. The interviewer would let you know you're on the right path, or no, that's not what I'm looking for. Let's find out. Let's make sure that we're aligned. So my second example case, let's kind of go through that step right away, is for this input-output case. And what I understand from this is we want to convert this binary tree. Some questions I would ask the interviewer is like, what am I actually receiving as input? Because a binary tree, we might think like, are we receiving an entire binary tree data structure where we have insert, remove methods along with methods to access the root node? Or are we getting just, let's say, the root node, the head node of a binary tree? And if that's the case, here's, I'll ask a question. And my interviewer says, you're going to receive the root node of this binary tree, and I want you to return the root node of this ultimate linked list. It's kind of like the head node. All right, and now looking at this, what I understand from here is that 1, 2, 4, that's 1, 2, 4, and then 5, which is this, this node right here, 3 over here, 6, 7, 8. So viewing this right now, my first intuition is we're traveling through this in a depth-first manner. We're traveling, let's say, as far to the left as possible, and then as we back up, we're then going to try the right, and we back up, try the right, try the left, there's nothing there, this 3 has no left node, travel to the right, the 6 has left node, try the 7, back up, try the right node, have the 8, and that results in what we have here. And looking at this also, I see that we have all these backslashes. I may ask my interviewer, okay, at this point, is it that we actually create a new linked list data structure type, or are we simply just making like a one node that has a right child, which is a 2, which has a right child, which is the 4, and so on and so forth? I'll ask that to my interviewer. And my interviewer says, I know I'm pretending to play both sides, but my interviewer says, yes, just make everything a dot right child. And I do indeed want you to traverse through this in a pre-order traversal. Okay, cool. So now let's create that second example case. And what I'll generally do also with that second example case is you want to create something smaller. Because when it comes to testing this out later on, if we have to test it out on something this big, we might end up spending more time than is actually needed. We could accomplish the same thing with something that's smaller. So I'm going to create something smaller right away. If I have an input where there's a single root node of 1, and that one root node has 2 children, one is the 2, and excuse me, the left node is a 2, the right node is a 3. I'm going to check my interviewer. Can I expect that as output, I'm going to have 1, 2, and then, oops, I'm running out of space. Let me put that on the next page. It's going to be 1, 2, and then a right child of 2 is going to be 3. Can I expect that that's what I should return as output? And what I return is actually just the root node of this. My interviewer says, yes, that is what we're indeed looking for. Cool. We're almost done with understanding the problem. Like, so far, we understand what we're looking for. What we've got is inputs and outputs. But lastly, you want to check about constraints. And when any of us here think about constraints, I think most commonly we think about time, runtime, space, additional memory usage. But there's other constraints as well, such as you can or cannot use this method or this particular data structure. So when you reach this part of the understanding step, just ask your interviewer, hey, are there any constraints to this problem? Leave it open-ended, and if they do mention anything, those are what you want to type down. So let's say for this problem here, my interviewer tells me there are indeed a couple of constraints. First of which, your runtime constraint is linear. So given a binary tree, you can do things that are kind of like one pass, or however large it is, we pass through the nodes a set number of time. So this is going to be linear. And for space, my interviewer tells me for this, it's also going to be linear as well. Cool. So we have those constraints. But my interviewer also tells me something else, that I cannot use recursion. And that is somewhat of a restrictive constraint, because what we've got here now, the fact that I can't use recursion, with the binary tree data structure, one of the traversals that exists out there, the depth first search, it's quite simple to implement this one using recursion. You can still do it iteratively, and there's actually a lot of there's some advantages to doing it iteratively, such as, let's say, not being restricted by the size of the recursive call stack, but it does require a bit more code that we'll have to write out, but it's fine. Those are our constraints. All right, what do we do next? We proceed on to step 2. And for step 2, we're now going to diagram out the algorithm itself. During step 2, this is kind of the meat of our algorithm creation process. This is where we pivot between different ideas, try out different approaches. And for this now, Dan mentioned this earlier in his slides, but we're now going to make use of something called ASCII diagramming. I'm going to diagram inside of the environment itself. We've kind of already been doing this. Even in the creation of this second example case, I made a binary tree data structure, and then I drew out a potential binary tree data structure as well as output. This is ASCII diagram. You're just diagramming out your thoughts in here. Certainly, if I had a notebook, a whiteboard behind me, a piece of paper, it would be easier for me to diagram these things out. And for many of you here, you're going to feel that same degree of comfort. Why we recommend that you use ASCII diagramming? Think of it like an investment. Why it's an investment? Because you're now fleshing out your algorithm, but you're fleshing out in a way that the interviewer can always see what's going on. Like, let's say if I'm writing on a piece of paper, I have to hold it up to the camera, but I can't be doing that the whole time. At some point, I have to drop it and start coding or whatnot. And at the end of the interview, what are they going to have access to is they're not going to have the paper. They're not going to have the whiteboard that's behind you. They're just going to have what exists inside of the Google document. So we're going to diagram inside of here as well. And let's get started with that. Let's use this example that we have here. And my approach for this, when we're going through the diagramming phase, is you're going to draw out or write out every single data structure that we're going to need, or every single variable that we're going to need in order to implement this algorithm. And for this, now to perform a depth first search, so let's actually write that down real quick. I plan to use a depth first search algorithm. And then for this algorithm, what we're going to have is I'm going to use a stack. And really, that stack is just going to be an array where we can push things to the stack, and then we can pop things from the stack as well. And all right, what's going to happen next? Like, how will the stack grow and shrink over time? And to illustrate that, let's actually not use it an array like there. I'm going to use something else. So let's draw our stack actually as kind of a pipe. So we've got this being our stack, and the stack is closed off in a sense. All right. And what we're going to do each time is I'm going to start at the root node. So if I start the root node, let's say I push that onto my stack. And what I want to do next, I plan to pop from the stack as well. So let's say our current element is this root node. We pop from the stack. And now this is kind of like what we're inspecting, what we want to act upon. And there's a couple of different things that we can see that need to happen. If we look at our input, 1 with a 2 is the left child, a 3 is the right child, ultimately that 2 becomes the right child. So what I want to do is I want to rearrange 1's dot right property to be that 2 node. Okay, so I can do that rearrangement, but before I do that, let's actually grab the 2 and the 3 nodes, and I'm going to push them into my stack. All right, so I push those into my stack, and now they exist in here. What I can do next is now I can take that 1 node and I can rearrange its dot right child. So let's say that we turn both of 1's left and right child now to be null. So there's nothing existing here. All right. And what can we do next is we can grab whatever is on the 2 side, and I can place that as the 1's right child. Okay. And what do we want to do at this point is we have the 2 child here, right? I'm going to pop that off of the stack now. And when I pop it off, does 2 have any children of its own? Nope, it didn't have a left and right child. So at this point, I would actually be done with this node. Um, and what's going to happen next is we're going to pop off from the stack once more. And I have a 3 node. And that 3 has to become my 2's dot right child. So what we can see here is that we have a 1 node, a 2 node, a 3 node, and we've rearranged all of their dot right references. And that's going to be our approach here. I see that there is one thing I was sort of missing as I was going through this, is we also need to have some sort of variable that lets us know what is the parent. So that if I'm modifying the 2's dot right property, I can modify it to be whatever pops from this stack itself. So let's do this one more time, just for demonstration purposes here and now. Let's revert this binary tree back to the way it looked from earlier. Let's see here. We've got our, let's see, there we go. 1, left child, right child. And the first thing we're going to do, let's have a parent. And I'm going to set that equal initially to the 1. And we push the 1 into the stack. And then we're going to pop that 1 from the stack. And what are 1's children? Let's just write those down real quick, the 2 and the 3. And once we put those in, we can obliterate the 2, or just sort of set 1's left and right properties to null. And all right, our parent is the 1. We've pulled out the current, we've grabbed its children, pushed those into the stack. Oh, and we actually didn't want to do 2 and then 3. We want to do 3 and then 2. And let's repeat the algorithm once more. We pop the 2. So that's now our current. And with this 2, we're going to set that parent.right is equal to whatever the current is. So that's going to be the 2 that we have here. And then I'm going to rewrite that parent now to be the 2 node. And does 2 have any children? Nope, it does not. So then we're going to grab the 3, pop it out. Oops. We have now the 3 node. And with the 3 node, we're going to take the parent.right, which is this 2's dot right property, and I'm going to set that to be our current, which is the 3. And now we can see that we have 1, 2, 3. So it's the dot right properties each time. And this matches what we have here in our output. So it looks pretty good. We're ready almost to go into the code, which would be our step 3, except for one thing. Remember earlier, we asked about constraints. And part of asking for those constraints, it wasn't just so that they could give you the time and the space constraints, tell you what you can and cannot use, or simply just because Ron told you to do this step as part of the process. But it is so that when you're creating your diagram, when you're creating an algorithm itself, in these sessions, the interviewer is gauging your process for problem solving. And part of that process involves you not really, being in this questioning sense where you're asking the interviewer, hey, is this right? Does this look correct? Am I on the right path? But you should be the one that actually tells your interviewer, hey, this looks right because we've got the correct output case, and also it fits these constraints. So looking at the constraints that we have here, linear time and linear space. Well, for linear time, that makes sense. We have to travel through every single node. That's going to happen regardless of how small, how large this binary tree is. And then for linear on the auxiliary space, this one can be a little bit trickier to gauge. But one of the ways to look at this is, let's imagine worst case scenario, this stack. This is an additional memory that we're using. Here, we had a more balanced binary tree where one node had both a left and a right child. But if we had something that was less balanced, for example, if we had, let's say, a 1 that had a left child of a 2, which it also had a left child of a 3. And you can see I'm just starting to make this look more like a linear list of sort. of sorts, where everything is just the left child of the previous ones. If this is just what we had here, then that means the 1, we push that in, we grab the 2, we grab the 3, we grab the 4, and each time, well, I guess each time we'd be pushing one in and popping one out. Grab the 1. So we push in the 1. Oh, so it's not actually this case that we have here. It'd be more the balanced version. So if similar to what we saw at the top here, 1, 2, 3, 4, 5, 6. If we had a more balanced tree here, where let's say the 3 had a left child of 5.5, something like that, then at some point we could have all of these nodes potentially in our linked lists at the same time. So that's going to be one of our concerns. So we're still under the linear space usage, so we're good for that as well. And because of that, that's how you can let your interviewer know, hey, I'm going to move on to the code now. So let's do that at this point. We've got our algorithm created here, and I don't have a lot of space down below, so I'm just going to create this all on a new page. And for our function here, I'm going to be writing this out in JavaScript. I'll just call the function itself convert. And this convert, it takes in the root node of our binary tree. So in this case, that was the 1 that we see here, or in this case, also the 1 that we see here as well, the root node. And what were some of the elements that we need in order to solve this function? This is where when you're creating your algorithm, right, you're going to do a lot of, let's say, going back and forth between the function, the actual code itself, along with your diagram. When you're doing that, whenever you're going back and forth and scrolling from one page to a different page, make sure that when you're referring to something, just highlight it. Remember, you're in a Google Doc. Anything that you highlight, your interviewer can see. So it's kind of like if you're, remember, pre-COVID times, if you're interviewing at a whiteboard next to a person, you just point at the board. Same sort of action that we're doing here. So what are some of the things that we need? We need to have a parent variable. We need to have a stack data structure, which I'm just going to use an array for. And we need to have a current variable. So let's create those real quick. We need to have a parent. So parent, I'm going to set that to be the root. What else do we need to have? Actually, I'm just going to set that to be no for now. We have our parent. We have our current. I'm going to leave that as undefined, or just also null for now as well. And we need to have our stack. For JavaScript people, the current and the parent, I use let because those are things that would change over time. For the stack, that's fixed, so I just use a const. For non-JavaScript people, pay no mind to me. Don't need to worry about that. Let's continue. So our algorithm, what did we need to do first? Well, we saw at the start, excuse me, we put that 1 node, the root node, inside of our stack data structure. So let's actually, at the start of this entire algorithm, let's take our stack and let's push that root node inside of here. Once we push that, would the interviewer confirm this point that you're on the right track, or would he let you code it even if it's not correct? They would let you code it even if it's not correct. That's the more, I would say majority of the time, they'll let you do that. And then what will happen next is, let's say you complete your code. If you run out of time, then that's just going to happen. But if you complete your code, at the end, they'll just say, is this correct or not? And then you'd have to go through testing it. Testing is different though, because I can't just, there's no compiling inside of a Google Doc. So that's where you would need to go line by line, and you're now acting as if you're the compiler. If it's something that's small, yeah, and I think what you're asking there, maybe it more so depends. If it's a small thing that you missed, potentially, they'll just let you go ahead. If it's something that's larger, or algorithm just simply, it's like it's very incorrect, or it's just not going to work for a lot of example cases, they may stop you then and wait for you to come up with something that's more correct. Okay, let's see. We pushed in the root node. So reverting this, I'm going to revert this once again. We've got this here. Going to place this back like so. Parent is currently no. And the current also no. And what did we do at the start? We just took our stack, put the root node in there, and this is everything we've done so far. We have pushed our root node into our stack. What needs to happen next is our algorithm itself, and I'm going to do what this while stack, let's see, while stack is not empty. or still has elements that we want to grab. So I'm just going to say while stack.length is greater than 0. And if this is the case, if the stack.length is greater than 0, this means there are still elements inside of our stack. And now we're inside of our while loop. And just so that we don't forget to do this later on, I'm actually going to take our root node. If we look back at our outputs that we're expecting up here, we have an input of a 1 here. We're expecting an output of that same root node later on. So I'm actually going to return, after this while loop completes, return our root. And everything else that happens inside of this while loop, that's where we rearrange our binary tree into the linked list type data structure. All right, and what is happening inside of this while loop? Well, first thing we wanted to do is set current equal to our stack.pop. We're going to remove that last element. And I see now I might need to not have my parent be a null. I might need to have my parent be a new tree node of no, empty. Cool, we'll just leave it at that for now. What I'm going to do next is once I pop this off, so currently I've got some dummy node here. So let's just make that a dummy node of no. It's kind of floating off by itself, and that's what the parent is. This dummy node that we see here. And what I'm going to have happen next is we just pop this element out from our stack. That means this 1, I need to make it the parent node's dot right child. So even though we don't really have this is nothing, because of need to have a dummy node from before, I'm going to set no node dot right is equal to this 1. So what we just popped off, we're going to set parent dot right is equal to current. So we've just made that connection now. And oops, I forgot to modify these variables as well to illustrate my process. Okay, what's going to happen from this point onward is now we have a 2 and a 3 children. We're going to grab the right child first, and then the left child. And here's why we grab the right child first. It's because later on, what do we want the 1's dot right child to be? We want it to be its left before the right. But since it's a stack, right? Whatever we push in first, first in, last out, whatever we push in first is going to be the last element to pop out. So we're going to access that 2 before the 3, which is what we want. We want that to become the right child of this 1. So we have the parent dot right is equal to current. And now the current, it's got a left and a right child, but it might have a left or a right child. We might think, oh, it always has a left and a right child, but there are instances where there might be something missing. And we don't ever want to push nulls into our stack because those aren't actual node positions themselves. So what I'm going to do at this point is I want to check if the current dot right actually exists. Then here, this is where I want to push into the stack that current dot right. And after we do this, we can also do the same thing for the current dot left as well. Only if they exist. So far, currently looking at the 1, we push in the right because it exists, and then the left. So we have the 3 and then the 2. And at this point, this is what our tree looks like at the moment. Once we push these in though, that's where I can obliterate these connections, the 2 and the 3. And the way I do that is for my current element, set its left and right to be no, so that there's nothing existing there anymore. So let's now set current dot left is equal to no, and do the same thing for current dot right. So I have removed these connections. So far, this is what we have. 3 and 2 sitting in our stack. Current is on the 1, and our parent is on the no. And we're almost ready. We're almost ready to move on to another iteration of this while loop, except for one thing. And that one thing is that we need to move the parent down. And why we need to move the parent down is because later on, when I pop this 2 out, I want 2 to become 1's dot right child. The only way that that can happen is if we rewrite the parent to now reference that 1 node that we have here. And that's it. Because what happens next? We've completed our while loop. Let's just do one more iteration with this while loop here. Current equals stack.pop. Current equals stack.pop. Okay, let's follow again. Parent.right equals current. So parent, which is pointing toward the 1, its dot right is equal to the current, which in this case is the 2. If current.right is not equal to null, if current.left is not equal to null, well, these are both not true. The 2 does not have any children, so I don't enter the if blocks. Current.left, current.right are both set equal to null. Well, they're already null, so kind of redundant at that point. And then parent equals parent.right. So now this parent would be 1 equals parent.right, which is now the 2. And eventually when we see that 3 gets popped up later on, it's going to become the 2's dot right child. And what happens at the end of all this? Once the while loop is complete, we return the root. And that root is still the same as before. It's just going to be our initial root that we have as input. And that is it. That's the entire process. Let's go through a quick recap of these steps. We've got 3 steps here. First, to understand the problem, then to diagram out, then code. Within the first understanding step, ask for an example case. Just to kind of recap of that. Ask for an example case, totally okay to do so. Create a second one of your own real quick, just to verify that you're on the same page as your interviewer. And then if there are any constraints, ask about them, but leave it open-ended so that if there are time constraints, if there are space constraints, and also if there are methods or data structures that we can or cannot make use of, have that all written out. When we go into the diagram, ASCII diagramming. Use it very much like you're in this environment itself. Do everything there. And this is going to especially be tough for some of you if you've never done it before. I mean, even if you've done it before, it's still like tough, but think of it like an investment. How to practice this really is that whatever platform you already use, let's say LeetCode, Code War, something like that, instead of using an IDE, using their environments that they give you, actually do this in a Google Doc. Try to go from start to finish and see, like, at the very end, once you have a solution you are happy with or you feel like this will work, copy and paste it in, test if it does. And that's where you're going to see, like, oh, wow, so many error cases, or, oh, it worked. That's how you can start to build that practice. Oh, and last step, coding it out. When we get to this step here, when you're building out the code, make sure you're going back and forth between the code and the diagram. And if you ever do so, always highlight things. Highlight to demonstrate to your interviewer what works, what doesn't work. And once you finish your code, remember, verify against the constraints once more. Does it fit? Does it not fit within those? And if it doesn't fit, like, or sometimes I've done this before myself, if you just completely forget about the constraints, you might get that question at the very end of your interview. Like, the interviewer will say, Ron, good job, you did well. But can we improve this? Or how can we optimize this? You know, that dreaded question, how can we optimize this? Because if they ask that, it must mean I must not have optimized it. But in any case, excuse me, let's test this out. I'm going to copy and paste this. And I know Dan did mention it earlier. Whatever you have here, it must compile. You can imagine that what they're going to do here, where I copy this code into an environment itself, and instead of calling this head, let's actually call this root, make it more consistent. So what I have here, let's say before we call this function, if I just run the page itself, I have just a tree node data structure, and I have this function called deserialize. Some of you are probably somewhat familiar with this, where deserialize takes in an array of inputs and creates the binary tree. And the binary tree it created here, this is similar to what we had previously drawn out here. So if I were to put this side by side, let's see, what do we want? Oh, it's not the root.right. Let's just do the root itself. So if we do the root itself, you can see that we've got a 1 node. So the initial tree node has a value of 1. Okay, it's got a left with a value of 2 and a right with a value of 3. So far so good. The 2 has a left and right of 4 and 5, which makes sense. And the 3 has a right child of 6. The 6 left and right child, they're kind of nested deeply. JavaScript does this thing where it just shows, once it is nested far enough, it doesn't show it quite as nicely. But we could still view that if we just said, instead, print out root.right. So if we do this now, we're just going to see the 3, and it's got a right child of 6, left and right of 7 and 8. So far, this looks like what we have. And we're coding here in JavaScript. Oh yeah, I might not have mentioned that earlier, but yes, we're doing this in JavaScript. Okay, and what do we do next? We have our function. Let's actually call this function convert on root itself. So at the bottom here, let's print out, oops, that's not how you spell that, on convert of root. And when we run this, let's see what we get here. Oh, let me comment out that, and let's actually put a label on this, the result. Okay, and what we have for the result, someone wrote this in the chat. Oh, can this be done in time linear and space constant? Oh, let's answer that in a moment. Let's inspect this real quick. Not exactly the easiest thing to see here, excuse me, but let's verify back at this. Root node, we've got a 1 node, has a right child of a 2, and that 2 has a right child of a 4, and then once we get past that point, it becomes nested. This is where one of the things you can do, but it does definitely ruin the formatting somewhat, is I could stringify that. And now it looks like this, definitely not friendly at all. But what we see here is now 1 has a right of 2, which has a right of 4, which has a right of 5, 5 has a right of 3, and then 6, 7, 8, 6, 7, 8. So yeah, we have converted this binary tree to a linked list. But this is not something that you would actually be doing during the session itself. This is what would happen following that technical screen where they're verifying your solution. Okay, so that is the process itself. We are already 5 minutes over on time. Oh, now it's 6 minutes. How coincidental. But we always do like to have some time for Q&A at the end. I do see some people have already typed some questions in the chat. Let's go back to Bhaskar's question about, can this be done in linear time and constant auxiliary space? So from the root, traverse the right side. If the current node has a left node, fold the right arm of the left node in the right arm of the current node. So fold the right arm of the left node in the right arm of the current node. Function convert let root while current is not equal to null if current.left. Perhaps it could be. I think this could. I think this could work. We definitely would need to have a temp variable that we set equal to the current.right. But I think there is a possibility that this could be done in constant auxiliary space as well. So yeah. It's almost like, yeah, we'd have a temporary variable to record this, and then we replace it with this. No, actually, never mind. Scratch that thought. Because if we could keep this as a temporary node, right? But then this 2 later on would need to keep this 5 as a temp. And yes, and if this 3 had like a left and a right child, we'd have to keep the 6 as a temp. So there would be multiple temps that we'd have to record or keep a record of, and that would, the number of them would not be a constant auxiliary space. It would need to be more. So I think unfortunately not, couldn't inspect that in a bit, but do want to open it up. If anyone has any questions, other questions that you may have, feel free to type those in the chat. Let's see. Are we allowed to put the code in an IDE and make sure it compiles? No, you are not. And definitely that's something that, well, they're in the Google Doc. They're there with you. They'll see it if you do that. So the whole practice here, like looking at the steps that we have, the thing they're really gauging is they want to gauge, is your grasp of whatever language you work in such that you can be a compiler? Such that even if it doesn't, if you can't run the code, you can still create something. You can still think through it. It's almost as if like you're using the code as a second language, in a sense. How do we know if it compiles? You won't, but how you can test it out is that once you've got the code written, you basically go, it's kind of like you back up from step 3 to step 2, and you act as if you're the compiler. You're now kind of like what I did here. We set parent initially to null, we set current initially to null, or excuse me, this is a null node, and then we rewrote those .write references along with pushing and popping things from the stack itself. I think there's some questions in the Q&A. I'm going to head towards those real quick. Oh shoot, my Q&A, for some reason, the window is, oh gosh, excuse me. Nope, that's not it. Oh, my window for the Q&A. Richie, if it be possible, could you copy and paste those into the chat? I'm having a little bit of trouble. I know this is not a good look for me right now. Like, man, he teaches this stuff, but he's got technical difficulties. Okay. But I have a little bit of trouble viewing them on my screen itself, actually. So if you could copy and paste those in, that'd be great. We got a question from Bhaskar. Does Google coding interviews do more than one question in a session? Yes, and the time at which we started this at about 7:30, I believe. This is Mountain Time. I'm in Salt Lake City, but that's where we started, and we ended about 8:05. So that was 35 minutes. If we multiply that by 2, that definitely goes over the hour allotment that you'll have. But you notice that through a lot of this, I was definitely kind of like teaching, talking throughout. So if I just like went straight through, solve this problem, that could have potentially been 20 minutes. But yes, the expectation is that you have or solve 2 minutes, not 2 minutes, you solve 2 questions during the session itself. Would the difficulty level of the questions be the same as this question? This question is fairly representative. It's got a couple of different elements. It's not just simply a traversal through its data structure, but it's also a traversal with keeping track of left and right pointers and reassigning them. So this level of difficulty can be expected. I would say, like, as far as the difficulty, it can go plus or minus to this particular problem itself, but this is fairly representative. Would it be good to just cut the chase and say we are going to use a DFS algorithm? Yeah, if from the very, like, what I did here, definitely more instructional. If from the start you're like, oh, let's use depth first search, and they say we can't use recursion, okay, we're going to do it iteratively, and you know it's going to make use of a stack. If there's already elements that you're quite like super familiar with, like what's going to happen, then yes, you don't need to. Here's the thing. The difference of what I did today is you're not an instructor. You don't need to teach the person this algorithm. They likely know multiple ways to solve this problem already. Your objective in that session is, well, think of it this way. There are 2 things that interviewers are always gauging during an interaction with you as a candidate. And those 2 things are your communication style and your process for problem solving. So at any given time, you letting them know, all right, we're going to use, I think, depth first search at this point. That's how we'll be able to always travel down the left side first and then back up, travel down the right side and so on. That's the communication part of it. And then your process for problem solving, that's these 3 steps. And if you proceed through some of these steps faster than others without like typing as much or need to diagram out as much, that's okay as well. Would it be good to just cut to the chase? Obviously, wow, yes, definitely communicating throughout. Okay, cool. I believe those were the questions. Any others? All right, well, let me just take this link and I'm going to share it into the chat once more. Just to make sure that everyone here, everyone present has access to it. And I'm also going to actually take the place where we called the code. I know not all of you here are necessarily JavaScript engineers, but try this out for yourselves. Try it out in a different language. And if you go on LeetCode itself, there are plenty of binary tree type problems there where you can start to practice this type of depth first search traversal by using a stack. All right, that is it for our session for today. I'm going to pass it back over to Dan.
Oh, Ron, that was fun as always. I always love watching your sessions.
Awesome. Glad to hear it.
All right. Well, everybody, want to thank you for coming by. If you would, give a shout out to Ron if you enjoyed it in the chat. Give him your thoughts there. It's always good for us to get feedback. And if you have any points, especially mine or Ron's for that matter, that you feel like could use some improvement, feel free to pop that into the chat too. Got a couple more minutes here. Sounds like everyone really enjoyed Ron's session. Bhaskar, thank you for the thanks there. Sean, you as well. Jackie, sounds like you really said a great mock interview with Ron. Stacy, thought it was very helpful. Keisha, helpful as well. That's awesome. Thank you all so much. Fatma, session, sounds like you enjoyed both. All right, that's awesome. Thank you so much, everybody. Really, really appreciate that. And again, not just fishing for compliments. So appreciate the feedback. But still have the the poll open for the info session. If you want to sign up, we're going to leave it open for about 10, 15, 20 seconds here. Just click the day you want to join the info session. Otherwise, going to move on to the next piece here. And again, I'm still here for Q&A. If anybody has any other questions, I'm happy to answer them. But otherwise, we're gonna get going. Or I'm gonna close the poll in 3, 2, 1. And here, I'll just share the results just so you can see. We've got 28 folks joining tomorrow's info session, 12 on Thursday, and 18 next Monday. All right. So one last piece. Again, we're putting together a beta Slack community here. We're pretty excited about this. We get people all the time asking us questions, asking for resources. And one of the best things that happens at Outco is we pull people together, sort of like the shared struggle thing. So we're trying to think of a way to do that, without having to have people come through the program. How can we offer something to the community, as it were, without you having to go through Outco? So we thought this would be a good way to go about it. This is all Richie's brainchild here. So hats off to Richie for thinking about this. But if you're interested, I'm going to share another poll here. And again, this is just, are you interested in potentially joining in our exclusive Slack community? It's free. It's at least it is right now. The beta anyway is going to be free. So if you think that might be something you want to check out, and we're looking for people who are really going to be, excited and interested in joining, and who want to contribute to help kind of foster the conversations, give us feedback on what channels you'd like to see, what you'd like to see differently. And the cool thing about joining right now also is that you can help shape it. So, 2 months, 6 months, 2 years from now, it's going to be its own big thing, and it's not going to change as fluidly as it will at the beginning. So you can really have an impact on what this becomes. So always fun to do. Appreciate the 3 folks who said no, and setting your boundaries and saying, that's not for me. That's okay. And actually, you know what? I'm going to share, I got that poll. We got 22 folks who said they're interested in it. Pretty dang cool. That's about half of the folks remaining. And I'm just going to pop into the chat here. We do have a link where you can, actually on our website, where you can check it out and sign up. Just enter in your info there. And yeah, we'll start getting that rolled up. Our alumni community is on a private Slack. It's really popular. We've got over 2,000 engineers on there already. So this is going to open up to all engineers. And so there'll be a lot of really good stuff on here, a lot of good conversations, a lot of good resources. People in your situation, you can bounce ideas off of. We'll have our staff in there answering things as well, providing resources. So should be pretty great. I definitely recommend it. Checking it out. Pretty exciting time to get involved in it potentially. Question I see in the chat. Are you recruiting at Outco currently? Typical recent grad question. Unfortunately, at this time, we are not, to my knowledge, on the technical, on either side. Actually, we actually have a pretty full team right now. So I wish I could be of help there. I'd love to say, you get a job and you get a job and everybody works at Outco, but unfortunately, no. But that's really great, Sankalp, that you're doing that. I really appreciate that. That demonstrates grit. That demonstrates you're putting yourself out there. A lot of people aren't gonna do that. So pretty cool of you to ask that. And again, the link to join to check out the Outco Slack community, it's in the Slack. Check it out, give it a click, enter in your info, and we'll be getting that rolling here pretty darn soon. So keep an eye out for emails. Again, if you're interested in Outco, would definitely recommend checking us out further, going to the info session, going to the visitor class. Take advantage of the resources we have for free. We got a good amount out there. Check out our blog. If you're interested in learning more about Outco, you can just apply. It's a great way to get to know more. You can set up time to talk to one of our someone here at the company one-on-one, and we can help work through any questions that you might have about your situation or advice. There's a lot of ways we can be of help without you having to join the program. So again, we're always out here trying to help as best we can. So regardless of whether or not you want to join or you want to move forward with us, no big deal. I would definitely recommend checking us out though. Again, that fundamentals check can be a good baseline for you to figure out where you're at with things. Um, Otherwise, I don't think I have any other goodies for you at this time. But otherwise, yeah, I don't see any other questions. I think we're probably going to wrap it up here. I really appreciate everybody coming by. You should feel good about what you're doing, by the way, regardless of what your goal is to get into Google, get into some other company, whatever it is. You're exploring something. We're kind of like a weird, like, what's an Outco? What is this career accelerator? What the hell is that? Just the fact that you're here exploring, having an open mind, sets you apart. I think that from the vast majority of other folks out there, and I think you'll see it in the results. Whether or not you join Outco, you should feel good about what you're doing right now, and I'm excited for you. So Jackie asked, does Outco accept applications of people who are still college junior? About my question, I might have missed it. Yeah, I don't think we had anyone ask that at this time. We'll accept the application. We might not accept you into the program just because I'm assuming you'd want to take a deferred payment option, and that would defer our investment in you for a year and a half, it sounds like. So at this time, no. I mean, you can apply and just find out if you'd be qualified on that front. And actually, a junior is probably a good time to apply because we can give you advice on what we'd suggest you do in the next year to make yourself look, as attractive as a candidate as possible on your resume. There's some things you can do that can really make you stand out. It's really easy for college grads, boot camp grads, self-taught folks to have, especially college grads, boot camp grads, to have very similar portfolios. They all roll out with kind of this, not always, but oftentimes they get sort of this cookie cutter project portfolio, and it doesn't really stand out. And unfortunately, a lot of universities, surprisingly, even master's programs, will have people doing like real simple CRUD apps that just really, really don't impress on the resume. So just got it. A lot of times there's other things, projects, internships, even if they're unpaid, project or contract work, even if it's unpaid, can all help you stand out. Even if you're a senior engineer and you're unemployed right now, hey, I picked up a contract building, the pizza place down the street, a website with an ordering system. Cool, you're doing something. It's better than sitting on your hands from the interviewer's perspective. If you're out there doing some sort of coding, especially if someone's paying you to do it or they're taking what you're using and actually implementing it, makes you much more valuable. And I know I always give more info than probably most people are looking for, so hopefully that wasn't too boring. But otherwise, I think we're gonna wrap it up. Sounds good, Jackie. Sounds like you got your question answered. All right, everybody. Well, on behalf of everybody here at Outco, Ron, Richie, Chad, and myself, would definitely like to thank you for coming by, and hope you have a good night, good rest of your week, and hopefully we'll hear from you soon. Take care, everybody.